Corporate environments often operate under a critical error in categorization, assuming that an annual performance review is synonymous with performance management. A performance appraisal, by definition, is a lagging metric. It is a strictly backward-looking evaluation that compares past output against a previously established standard. Performance management is a dynamic, forward-looking architectural system. It operates as a continuous loop, cycling through goal setting, the appraisal itself, and subsequent employee development. The purpose of this cycle is to force strict alignment between a single employee's daily tasks and the macroeconomic strategy of the entire company. Within this architecture, the appraisal node acts as a primary stress point. The data collected here feeds directly into compensation, promotion, and retention decisions. If the appraisal metric is flawed, the resulting data is corrupted, and the entire management system fails to execute its purpose. The central tension in HR systems engineering is the difficulty of translating subjective human behavior into objective, scalable, mathematical data. The moment one human evaluates another, the observation is subjected to structural cognitive errors. The raw data becomes contaminated by the rater's own psychology. The most prevalent statistical error is central tendency. This occurs when a manager defaults to grading every subordinate as average. It is an administrative defense mechanism used to avoid workplace conflict or the complex paperwork required to justify exceptionally high or low ratings. Conversely, leniency and strictness occur when a rater pushes all performance data uniformly to the extreme high or extreme low end of the scale. In both cases, the metric loses its variance, rendering it useless for comparing employees. Raters are also vulnerable to the Hazel effect, where a subordinate's excellence in one specific trait blinds the supervisor to deficiencies across all other categories. To build a functional organization, architects must engineer structural tools designed specifically to neutralize these cognitive biases. The baseline standard for corporate evaluations is the Graphic Rating Scale. This document is a standard graphic rating scale. It lists specific traits, such as quality or productivity, paired with a quantitative range. Look at the rating identification key. Supervisors evaluate the trait by selecting O for outstanding, V for very good, to U for unsatisfactory. Here's a variation of the same scale, engineered specifically for administrative roles. Instead of letters, this version uses a numerical scale from 1 to 4 to quantify how well the employee maintains departmental personnel records. The architectural flaw in this system is interpretive ambiguity. What exact observable behavior defines the difference between a 3 and a 4? Because the behavioral standards are entirely undefined, graphic rating scales offer high administrative efficiency, but leave the resulting data highly exposed to leniency and central tendency. To counter leniency and central tendency, organizations deploy relative ranking methods. These systems apply mathematical constraints to physically prevent a rater from giving everyone the same score. This is an alternation ranking scale. A manager must identify the absolute highest ranking employee for line 1, then the absolute lowest for line 20, alternating inward until the entire team is ranked. While alternation forces a curve, it relies heavily on a manager's overall gut feeling. To make the ranking process rigorously mathematical, engineers deployed the paired comparison method. Looking at the left chart measuring quality of work, we see a strict matrix architecture. Every employee is pitted directly against every other employee on the team. Tracing Maria's column vertically, the plus signs indicate she outperformed Art, Chuck, and Diane in work quality, but the minus sign shows she lost her head-to-head matchup with Jose. By forcing binary micro-decisions between two specific individuals, the system calculates an undeniable mathematically ranked hierarchy. The vulnerability of forced ranking matrices is their core assumption. They assume a team's talent maps perfectly to a bell curve. If a manager has successfully assembled a team of exclusively high performers, relative ranking mathematically forces excellent workers into the bottom quartile. Objective data requires qualitative context, not just forced math. The critical incident method pivots away from abstract mathematical rankings and grounds the evaluation in observable reality. Under this protocol, supervisors maintain continuous, year-round logs of uncommonly good or undeniably undesirable work behaviors. This table displays the raw behavioral data collected for an assistant plant manager over a review period. Notice the exact phrasing in the top right cell. The manager decreased late orders by 10% and increased machine utilization by 20%. This is hard, factual evidence of performance, offering a massive upgrade in clarity over checking an ambiguous outstanding box on a standardized form. But qualitative logs introduce a scalability problem. Narrative paragraphs are mathematically useless. You cannot plug an anecdote into a spreadsheet to calculate a division-wide bonus structure. The ultimate engineering challenge in performance management is synthesizing these two approaches. We need the scalability of a numerical scale, anchored strictly by the undeniable proof of a critical incident. Behaviorally anchored rating scales, or BARS, represent the optimal synthesis of quantitative scaling and qualitative evidence. Developing a BARS requires a strict 5-step process, beginning with subject matter experts generating hundreds of specific critical incidents of effective and ineffective performance. Step 2 clusters those incidents into 5 to 10 core performance dimensions, as seen in this mapping for grocery checkout clerks. Notice the exactness of the dimensions, actively separating skill in operating register from skill in bagging. In steps 3 and 4, a second group verifies these clusters. They then evaluate how effectively each incident represents the dimension, assigning it a strict numerical value, typically from 1 to 9. Finally, step 5 generates the finished instrument, locking the specific verified behaviors directly to the integer scale. This is the completed BARS tool for evaluating a Navy recruiter's salesmanship skills. The vertical axis represents the quantitative score. Looking at the anchor for a 9 rating, we read the exact qualitative incident. When an applicant didn't qualify for the nuclear program, the recruiter successfully pivoted them to electronics by emphasizing technical training. If an employee exhibits this specific behavior, there is no debate, no leniency, and no halo effect. They receive a 9. BARS strips out interpretive ambiguity. It creates a highly reproducible evaluation matrix that transforms subjective human action into verifiable objective data. Selecting an appraisal system requires assessing logistical trade-offs. Graphic rating scales are cheap and simple to deploy across an organization, but yield data highly prone to cognitive bias. BARS provide highly accurate, legally defensible data, but are notoriously difficult, time-consuming, and expensive to engineer. Regardless of the mathematical precision of the tool, the validity of the data relies entirely on the individual rater. Organizations attempt to balance this by changing who does the rating, integrating peer appraisals, subordinates, or 360-degree feedback to widen the perspective. But a perfectly engineered metric yields nothing if the manager deploying it lacks the training to assess performance without bias. This returns us to the initial paradox. Accurately measuring the data is only half the equation. The data must be utilized. The indispensable final step of the performance management loop is the appraisal interview. This appraisal coaching worksheet converts backward-looking data into forward-looking strategy. Question 5 forces the manager and subordinate to identify knowledge gaps and map out exact skill development needs. Question 6 then formalizes these results by establishing mutual objectives for the next cycle. An appraisal that does not conclude with a new set of defined, measurable goals and a clear development plan is not performance management. It is just bookkeeping.